These examples are of special cases of discriminant questions where you need to be aware that the quadratic may reduce down to give you further solutions to the discriminant problem. Now, the three cases that you have to be aware of in all these questions are when discriminant is greater than 0, you have two distinct real roots. When the discriminant is equal to 0, you have one repeated real root. And when the discriminant is less than 0, you have no real root. Also, you know that quadratics are of the form y equals ax squared plus bx plus c. And you're using quadratics to normally find the discriminant. You can only find discriminants of quadratics. But just be aware when you have these sort of problems, what is happening when the coefficient in front of x squared is 0. When a is equal to 0. So what is happening at that point? What happens to your problem when a is equal to 0? Okay. So let's go through a few examples to help you understand this. It says, find the range of values of k for which kx squared minus 2x plus 5 equals 0 has one solution. Okay, one solution implies the discriminant must be equal to 0. Okay, we've got kx squared minus 2x plus 5 is equal to 0, which implies a is equal to k, b is equal to negative 2, and c is equal to 5. So if we calculate the discriminant, which is b squared minus 4ac, I get negative 2 squared minus 4 times k times 5. My negative 2 squared gives me 4, minus 4 times k times 5 gives me negative 20k. Now we know in this case we've got discriminant is equal to 0, which means 4 minus 20k must be equal to 0, which means 4 must be equal to 20k, so k must be equal to 4 over 20, which means k is equal to a fifth. So that is the solution. And that's where most students would stop. But what happens, remember, when the coefficient in front of x squared is equal to 0? How does it affect the solutions that we get? So let's look at that example. So when k is equal to 0, okay, what happens to this? Kx squared minus 2x plus 5 equals 0 becomes negative 2x plus 5 is equal to 0. So this quadratic reduces to a linear. Now, if we solve this linear, are we getting one solution? So if I solve this, I get negative 2x is equal to negative 5, which means x is equal to negative 5 over negative 2, which means x is equal to 5 over 2. I do get one solution. So remember, we were trying to find the values of k for which this equation has one solution. Here, when k equal to 0, I'm getting x is equal to 5 over 2, which is one solution. So that means k equals 0 is also a solution. So my solutions are both k is equal to a fifth and k is equal to 0. So most students would forget about the k equals 0 as a solution. So let's look at this graphically and see what happens. So as you can see, when k is equal to negative 0.45, there are two x-intercepts. And in this problem, we're trying to find when it had one solution. So if I change the value of k, if I decrease it, you can see there's two intercepts always. But if I increase it to 0, you'll see a funny thing happen at 0, where the curve became a straight line and it has one solution. So k equals 0 is a solution. If I make k slightly bigger, it doesn't let me stop at 0.2. at 0.2 you can see it's got exactly one solution. If I make it a lot bigger, then it will see, if I make it bigger than 0.2, I don't know why it's doing this funny thing, you can see there's no solutions. Okay, one more example. Find the range of values of k for which kx squared minus 2kx plus 5 equals 0 has no real solutions. Okay, so first thing is, if it has no real solutions, it implies the discriminant must be less than 0. So we've got kx squared minus 2kx plus 5 is equal to 0. So my a in this case is k, my b is minus 2k, and my c is 5. So if I work out my discriminant, b squared minus 4ac, which is negative 2k all squared, minus 4 times k times 5. Negative 2k all squared gives me 4k squared minus 20k. Okay, and I know the discriminant is less than 0, which implies 4k squared minus 20k must be less than 0. If I divide through by 4, I get k squared minus 5k is less than 0. I factorize it, I get k times k minus 5 is less than 0. If I do a rough sketch, I know this goes through 0 and 5. It's a positive k squared, so it looks like this. I want the part that's less than 0, so below the x-axis, which means it's all the values of k between 0 and 5. So k is less than 0, which is less than 5. K, which is greater than 0, which is less than 5. So like this. Okay. Now I need to look at when my coefficient of x squared is equal to 0. So when k is equal to 0, what happens to my equation? Then kx squared minus 2kx plus 5 is equal to 0 reduces to kx squared becomes 0x squared minus 2kx becomes 0. So all it reduces to is 5 is equal to 0. Now this statement is false. Because this statement is false, then that means when k equals 0, so when k is equal to 0, there is no solution. Also gives no real solution because it's giving me a statement that's obviously not true. 0 can never be equal to 5. So that means k equals 0 is also included. So 0 is less than k is less than, whoops, let me rewrite that. So 0 is less than k is less than 5 is a solution as well as k is equal to 0. Now that means I can rewrite it all as 1 because 0 is less than k is less than 5 is a solution. But because we're including 0 as well, I can put k is greater than or equal to 0. So that would be my final answer. Okay, so it wouldn't be that one. Okay, so always look at the case where x squared becomes 0 and see if something happens there and it gives you a solution. So we want the case where, remember, there are no real solutions, so when we have no x-intercepts. So let's increase the value of k. So let's see what happens at k equals 0. At k equals 0, it reduces to a line going through y equals 5. So it's the line y equals 5, so which has no real solutions. So k equals 0 does give you no real solutions. And if you look at everything between 0 and 5, you're getting no x-intercepts, so no solution. When k is greater than 5, you see you'll have 2 x-intercepts. I'm guessing at k equals 5, it's a repeated root. Okay, and if it's k is negative, you can see that you still have to intercept. So everything between 0 and 5, including 0, does give you no real solutions.